Okay, so now we're going to do an example of calculating the change in enthalpy for a reaction using standard enthalpies of formation. So here's a typical problem. Calculate the change in enthalpy, or the delta H reaction, for the following reaction, which is calcium oxide solid reacting with carbon dioxide to make calcium carbonate in the calcite polymorph. Okay? And so we are given the following information that we could also find in the table of thermodynamic quantities. And these are delta H of formation, or the standard enthalpies of formation for each one. So we have calcium oxide, carbon dioxide, and calcite listed there. And what we want to do is use those to calculate the change in enthalpy for the reaction. So let's remind ourselves of the equation that we're going to be using. And that is delta H reaction is equal to the sum of the moles of the product, each product, multiplied by the delta HF, or the standard enthalpies of formation for the products. We're going to subtract off the sum of the same thing for the reactants. Okay, we're going to take the moles of each reactant. Oops, I have an F there instead of an R. So we're going to take the moles of each reactant and multiply it by the standard enthalpy of formation for each reactant. Okay. All right, so that's our basic equation. So what we want to do is find the values for each one of the reactants and products in our reaction, and then just sum up all the products and all the reactants. So let's go ahead and do that. All right, so let's plug in what we actually have first. Okay, so delta HF reaction. This is kind of like planning it out. Okay, we're going to do products first, and so we just have calcite, and we only have 1 mole because the coefficient is 1. So we're going to have delta HF calcite. Okay, and then we're going to subtract off the sum of our reactants. Okay, so we have 1 calcium oxide, so 1 times delta HF of calcium oxide, solid. Okay, and we're going to add to that 1, because the coefficient of 1 for carbon dioxide. And there we are. So we have carbon dioxide gas. Okay. All right, so now we're all set up to plug in all of our values. All right, so delta H reaction is equal to 1 times negative 1207.6 kilojoules per mole. Okay, I'm going to leave off the units for room, but let's just remember to put them back on at the end. Okay, and then now we're going to subtract off our reactants. Okay, the delta HF for calcium oxide, if we go up here, we see that it's negative 634.9 kilojoules per mole. Again, we'll put on our units at the end. And finally, carbon dioxide, we have 1 mole of that also, and it is negative 393.5 kilojoules per mole. All right. And then now basically the biggest pitfall in these problems is either forgetting to put in the coefficient in front of the heat of formation for each reactant and product. And in this case they're all 1, so this is pretty easy. But the other pitfall is signs. Okay, so notice just we have a negative sign here. Okay, and then these are both negative also. So these are going to end up being positive quantities in our final calculation. Okay, so let's just go ahead and finish this up. Okay, so delta H reaction is equal to negative 1207.6 plus 634.9 plus 393.5. Okay, and we're going to end up with negative 179.2 kilojoules per mole. Okay, so just putting our units back on there. All right, so this is an exothermic reaction. It releases heat. And if we were to reverse this reaction, would we have an endothermic or an exothermic reaction? So if we reverse the reaction and we make calcium carbonate or calcite going to calcium oxide and carbon dioxide, what would the sign of delta H be then? And if you said positive for reversing the reaction, you would be right.